This video will cover the basics of neutralization reactions. To start with, you have to understand what a neutralization reaction is. This is when an acid and a base come together and cancel out so that we have an overall neutral pH, or a pH of 7. The general formula of this type of equation is acid plus base yields H2O plus salt. A salt in this case can just be any ionic substance. As a couple examples, hydrochloric acid plus sodium hydroxide yields water and sodium chloride. As another example, hydrobromic acid plus calcium hydroxide yields water and calcium bromide. Now you might notice here that one of the equations has some coefficients and the other one doesn't. The reason is because we need to make sure that the moles of hydrogen ions equal the moles of hydroxide ions in a neutralization reaction. Also, as with any chemical reaction, it's important that the equation is balanced. So focusing here on the acid and base parts of this equation, in that first example, we had one hydrogen in each hydrochloric acid molecule and one hydroxide ion in each sodium hydroxide. And so those came together to form one water, and we get H plus OH minus, yielding one water. However, in the other reaction, we needed two hydrobromic acid molecules to cancel out with one calcium hydroxide. So we have two hydrogen ions plus two hydroxide ions, and that's going to make two waters. Neutralization reactions should always balance out in this manner so that we only get water in the end, and the salt in this case, which is calcium bromide. Another key idea that you need to use when going through neutralization reactions is the molarity. So as a reminder, the molarity is the moles of solute divided by the liters of the solution. You can rearrange that equation to say moles equals molarity times liters. Now I'm going to go through a couple example problems. So this problem says 45.0 milliliters of acetic acid is exactly neutralized when 35.0 milliliters of 0.1 molar barium hydroxide is added. Calculate the concentration in molar of the acetic acid solution. I'm going to mention here that acetic acid is vinegar, so it's a very common weak acid. So in step 1, you need to write the balanced chemical equation. I've got that for you here. And many times when you go through the math problems, we'll just give you the balanced chemical equation. But you need to know how to match it up so that you've got the right number of hydrogen ions and hydroxide ions. Because acetic acid only had one hydrogen and barium hydroxide had two hydroxides, we needed two acetic acid molecules to match up with the one barium hydroxide. In step 2, you need to find the moles of what's given in the problem. This is going to be the substance which you have more information about. Because I gave you both the milliliters and the molarity for barium hydroxide, we have more information about that substance. So we can figure out how many moles of barium hydroxide we have. The moles are equal to the molarity times the liters. So for barium hydroxide in this case, we have 0.100 molar times 0.035 liters. The reason this number is different from what's given above is because we need to convert from milliliters to liters. Molarity is measured in liters. To get from milliliters to liters, you divide by 1,000. So that's how we ended up with 0.035 liters. You multiply those two numbers together and you get that there are 0.00350 moles of barium hydroxide. Because this is a neutralization reaction, we know that the moles of the base need to completely cancel out with the moles of the acid. And to ensure that's the case, we can use the mole ratio from the problem. So we start with a 0.00350 moles of barium hydroxide we had from step 2. And then we look at the coefficients to determine the mole ratio between barium hydroxide and acetic acid. Based on the coefficients, you can see that there are 2 moles of acetic acid for every 1 mole of barium hydroxide. When you multiply by that conversion factor, you get that you would need 0.00700 moles of acetic acid for this neutralization reaction. As a last step, we need to find what's missing in this problem. This is usually the question that is asked directly in the problem. So this one said, calculate the concentration, molarity, of acetic acid, of the acetic acid solution. So that's the last step. We're going to find the molarity here. Remember that molarity is moles over liters. The moles from step 3 were 0.00700 moles of acetic acid, and we divide this by the volume. Again, we converted from milliliters to liters because molarity is moles per liter. To get from milliliters to liters, you divide by 1,000. So we have 0.0450 liters. When you do that division, you get that the final concentration is 0.156 molar acetic acid. As a second example, we have this problem. What volume of 2 molar sodium hydroxide is needed to completely neutralize 175 milliliters of 0.6 molar hydrochloric acid? As step 1, we're going to write the balanced chemical equation. Hydrochloric acid has 1 hydrogen, and sodium hydroxide has 1 hydroxide. And so, in this case, everything's 1 to 1. There are no coefficients needed to balance the equation. The substance we know more about in this case is hydrochloric acid because we are given both the volume and the concentration for hydrochloric acid. That means we can figure out the number of moles. Moles is molarity times liters, and so for hydrochloric acid, this is 0.600 molar times 0.175 liters, and we get that there are 0.105 moles of hydrochloric acid. The next thing we're going to do is use the mole ratio to figure out how many moles of sodium hydroxide there are. Because it's a 1-to-1 ratio, we see that we have the same number of moles of hydrochloric acid as we do of sodium hydroxide. As the last step here, we're going to answer the question, which was what volume of 2 molar sodium hydroxide is needed. And so volume, when we rearrange the molarity equation, is equal to moles over molarity. So we take the number of moles from step 3, 0.105, and we divide it by the molarity, 2.00, and we get that there are 0.0525 liters of sodium hydroxide needed. Now, it's good practice to convert the volume back to the original units it was given in. So we take the liters and we multiply by 1,000 to get it back into milliliters.